Okay.
Okay. So the formulas we're using to get the y coordinate, want to get the y coordinate of the centroid. This is going to be y tilde dv over the integral of dv. So here we're going to pick a disk that are going to rotate about the y-axis. So we're going to rotate that about the y-axis.
Mm.
So let's say this is such a disk. So of course, the way it is, that's just a ring. So to make it a disk, we're going to put a counterpart there. Now, this has to be a thin disk. So this disk comes up to the top there. The radius runs from here up to that point. So the radius of this disk will be equivalent to the z value at that point. So the radius will basically be equals to z. So if wanted to get the volume of that disk, the volume, since it's a selected section, will be dV, will be equal to its area, pi, the radius squared, multiplying the thickness of the disk. The thickness in this case is in the horizontal axis. And the horizontal axis is labeled as a y. So this is going to be a thickness in the y, a dy. This becomes the expression that gives us the volume. Notice that we did point out that the radius is equals to z. So we now have dv is equals to pi. Where there is r, we're going to put z there. So this will be z squared dy. Now, since what we have here is dy, we don't want this to be z. We want it to be written in terms of y. So on top there, we have a connection between x and y, or between y and z, because this is going to be a coordinate y, z. So from there, we see that z squared is actually just equals to 4y, meaning where we have z squared here, we can just put 4y. So that our dv now will be equals to pi, where is z squared, we'll put 4y dy. So our dv simplifies to just be 4 pi y dy. Since now we have z, we now have dv. The next thing that we need is y bar. So the next thing that we need is going to be y bar. So how are we going to get y bar for this section? Not y bar, y tilde. Y tilde is the y coordinate of the centroid for this shape. So for the disk we have selected, its centroid lies right at its midpoint. So this disk, its centroid will be somewhere exactly on the middle. You agree?
Yes.
And for this point, you have to see that the y value is the same as the y tilde will basically be the same as the y coordinate at that point. Because above all, this point will lie right below that blue point on top, the one which has a y. So because of that, y tilde will be equals to just y. So from there, we can get y bar. Y bar is the integral of y tilde, but y tilde is y. Multiplying dA. dA turned out to be 4 pi y dy over the integral of dA. Again, 4 pi y dy. So this can now be written. We can factor out the constants since they will not be affected by the integral. Y and y will give us y squared over the integral of y dy. We now need the limits of integration. Since this is with respect to y, we need the smallest value of y to the largest value of y. What's the smallest value of y here?
Here.
And what's the largest value of y?
4.
4. So y is changing from 0 to 4. Oh, and you have to see there's this 4 pi also in the denominator. So the 4 pi in the numerator and in the denominator, they will cancel, leaving us with only the integral of y squared dy over the integral of y dy. When we integrate here, we get y to the power 3 over 3 over y to the power 2 over 2. From 0 to 4, from 0 to 4. When we plug in the upper limit only, we're going to have 4 to the power 3 over 3 divided by 4 to the power 2 over 2. What would be the answer here? Eight over 3? 8 over 3. And then the units. The lengths here were given in meters, so this has to be in meters as well. So there we have it. Y bar will be equals to 8 over 3 meters. You can write that 3 better. But if we're giving the full coordinate, it will be 0, 8 over 3, 0. Representing it as x bar, y bar, z bar. You're saying it's supposed to be what?
64 over 3.
The final answer?
Yes.
Okay, so the final answer you're saying it's 64 over 3. So when you divide this 64 by 3, what are you getting in decimal?
That's 21.3.
1.3.
3.
Okay, so it should make sense to get an answer. When you bring it here, notice that 21.3 doesn't make sense. Since it's a y coordinate, but we're saying that the y values are changing from 0 up to 4. How can it be 21? 21 is somewhere else. That would not make sense. Do you see that?
Yes.
So you have to do this again. The denominator will obviously be 16 over 2. 16 over 2 will be 8. So the denominator, you currently have an 8 there. The numerator, you have 4 by 4 by 4. What would that be?
4 to the power 5.
4 to the, this is 4 to the power 3.
Hey, so that's fine because I've seen it as 4 to the power 5.
That's 3. 4 to the power 3, sorry. Once I will have 4 to the power 3 over 3 multiplying 2 over 4 to the power 2. So this will cancel with that, giving us 4 by 2 over 3. We are right on this in the first case.
8 over 3, because I looked at it, it looked like 5, so I put a middle stage.
It's at 8 over 3. So the question was only asking for y bar, so our y bar has been found as 8 over 3. So y bar is equals to 8 over 3 meters. So you've seen how to troubleshoot your values, how to see if they make sense. Just check. Does it make sense that the value is what I found? Also, if you find a value y bar, maybe it's equals to 0.2 meters, you should see that that would not make sense. Since you have more volume this side than this side, it doesn't make sense that the y coordinate has to be closer to 0. If anything, it has to be closer to 4. You get that, huh?
Yes.
Yeah, so you can always just think through your values to make sure that they actually make sense.